The northern flicker does not behave the way it is supposed to. In a family defined by vertical movement, birds that climb, cling, and hammer, the flicker spends an unusual amount of time on the ground. This single behavioral divergence reshaped its anatomy, diet, and relationship with the landscape. Evolution rarely rewards rebellion, yet the northern flicker thrives because its deviation solved a problem others ignored. Ants, billions of them, spread across open ground, largely untouched by other birds. Where competition is low, opportunity expands. Unlike tree-bound woodpeckers, the flicker evolved longer legs and a more horizontal posture, allowing efficient walking and probing. Its bill, still strong enough to excavate wood, is equally effective at breaking into ant colonies. The tongue, long and barbed, coated in sticky saliva, becomes a precision tool rather than a blunt instrument. Coloration reflects this dual lifestyle. The spotted chest breaks up outline against ground vegetation, while flashes of yellow or red beneath the wings serve as in-flight signals. The bold black crescent on the chest functions as species identification, visible even at distance. Migration patterns vary by region. Some populations remain year-round, others move south with winter. This partial migration reflects flexibility rather than indecision. The flicker does not commit to a single strategy, it evaluates conditions and responds. From the start, the northern flicker's story is about choice. Not instinctual rigidity, but adaptive option-taking. Ants form the backbone of the northern flicker's diet. Few birds can consume them in such volume. Flickers tolerate formic acid, the ant's chemical defense, with minimal consequence. This tolerance opens a food source that remains abundant even when other insects decline. Feeding sessions are deliberate. The flicker probes soil, listens for movement, then commits. Energy efficiency governs behavior. There is no frantic digging, only calculated effort. This patience is survival math. Vocalizations differ from other woodpeckers. The flicker's calls are loud, rolling, and carry over distance. Drumming exists, but sound communication relies more on voice than percussion. These calls establish territory, attract mates, and coordinate spacing. Breeding behavior blends tradition and improvisation. Nest cavities are excavated in dead or decaying trees, often reused by other species later. The flicker becomes an ecosystem engineer, creating resources it does not exclusively control. Pairs cooperate closely during nesting. Incubation is shared. Feeding duties rotate. This cooperation increases chick survival in unpredictable environments. Yet mortality remains high. Ground feeding exposes flickers to predators. Vehicles, habitat loss, and competition for nesting sites add pressure. Adaptation reduces risk, it does not eliminate it. The northern flicker is widespread, but its importance is underestimated. By controlling ant populations, it influences soil dynamics. By creating cavities, it supports secondary nesters. By adapting to open and wooded habitats alike, it links ecological zones. Human-altered landscapes present mixed outcomes. Lawns provide ants, power poles offer drumming platforms. But pesticide use reduces prey, and modern construction removes dead trees essential for nesting. Climate variability shifts migration behavior, alters breeding timing, and changes prey availability. Flexibility helps, but only within limits. The northern flicker survives by refusing to specialize too narrowly. It walks when others cling. It feeds where others ignore. It adapts without abandoning its identity. In a natural world shaped by rules, the flicker thrives by bending them. The northern flicker does not simply live in a place, it memorizes it. Ground-feeding birds depend heavily on spatial memory, and for the flicker, this ability is refined to acquire precision. Feeding grounds are not random patches of earth. They are remembered locations, lawns where ants consistently emerge after rain, forest edges where soil warmth persists longer, clearings where disturbance exposes colonies. This memory-driven foraging allows the flicker to minimize wasted movement. Energy is conserved not by speed, but by accuracy. Each step on the ground carries risk, and unnecessary exposure increases the chance of predation. Knowing where to feed is as important as knowing how. Landscape fragmentation tests this system. As continuous habitats break into smaller patches, memory maps lose coherence. A territory that once offered predictable food and nesting sites becomes a puzzle of disconnected fragments. The flicker adapts by expanding its range, but expansion brings conflict, with rivals, with vehicles, with unfamiliar predators. Flexibility, often praised as the flicker's greatest strength, carries hidden cost. A generalist must constantly evaluate changing conditions. There is no single fallback strategy. When ants decline due to pesticide use or drought, the flicker shifts to beetles, berries, or larvae, but each shift reduces efficiency. Survival becomes a balancing act rather than a stable routine. The flicker's nervous system reflects this demand. Heightened alertness, rapid reassessment, and constant movement tax cognitive resources. Chronic stress does not kill immediately, but it erodes reproductive success over time. Fewer eggs, lower chick survival, slower population recovery. Adaptation buys time. It does not guarantee permanence. The northern flicker occupies a biological borderland. It is neither fully arboreal nor fully terrestrial, neither strictly migratory nor entirely resident, neither urban specialist nor wilderness dependent. This in-between status defines its identity. Such species often go unnoticed. They are common enough to avoid alarm, adaptable enough to avoid immediate collapse, yet vulnerable enough to decline quietly. Conservation attention gravitates toward extremes, the rare, the iconic, the massive. The flicker slips between categories, yet its ecological role is disproportionate to its visibility. By regulating ant populations, it influences soil aeration and nutrient cycling. By excavating cavities, it provides nesting opportunities for birds, mammals, and insects that cannot carve their own. By moving between open ground and forest, it transfers energy across ecological boundaries. The flicker is also a messenger species. Changes in its behavior often signal deeper environmental shifts. Earlier breeding suggests climate instability. Increased urban presence hints at habitat compression. Declining drumming sites reflect the loss of deadwood, a subtle but critical resource. Culturally, the flicker lacks the symbolic weight of brighter songbirds or larger raptors. It does not dominate flags or folklore. Its story is quieter, more practical. It survives not by spectacle, but by adjustment. In evolutionary terms, this may be the most honest strategy available in a rapidly changing world. The northern flicker does not insist that the world remains stable. It learns the new rules and tests their limits. Sometimes it succeeds, sometimes it does not, but it continues to try, step by deliberate step, across ground its ancestors were never expected to walk. In that persistence lies its meaning.